I want you to try this. Use the picture here because you can't really see the colors on yours. But I want you to try to figure out what the theoretical probability of each of spinning a red, so the first one, probability of spinning a red. Second one, probability of spinning a 1. Probability of spinning an odd number. And the probability of spinning a number less than 7 is. So please pause the video right now and go ahead and try to solve those four in fraction form and make sure they are reduced. Alright, go ahead. Okay, so I hope you definitely paused the video and got some answers for these probability questions. Alright, so in theory, if we were to spin a red, well, you say how many reds are there on that spinner? There are 2 reds, and how many total numbers? 6. That can be reduced to 1/3. Alright, looking at 1, probability of spinning a 1. How many 1s are on the spinner? Well, there's only 1 1 on the spinner, so that's the number of favorable events. And then how many numbers are on the spinner? 6. So 1 6. C, spinning an odd number. Well, 1 is an odd number, 3 is an odd number, and 5 is an odd number. So I have 3 odd numbers on that spinner out of 6, which is half. And probability of spinning a number less than 7, well, all of the numbers are less than 7, so I would say 6 out of 6, which is just 1. Okay, so now we've talked about theoretical probability. In theory, what should happen? Experimental probability, you see that keyword experiment. That's what actually happens, okay? So we're going to conduct an experiment, or the question is going to give you data, or some type of results so that you can note what the experimental probability is. Alright, so please go ahead and fill in the experimental probability format. So we have number of times the desired outcome occurs, which is on the numerator, divided by the total number of, or the number of total trials. Alright, so in number 12, we're going to look at this data in the graph, because it says we're looking for experimental probability. Okay. Question 12. You roll a number cube 50 times. 50 times tells me that's the number of total trials. So it's going to be on my denominator. Okay, the results are on the right. What is the experimental probability of rolling a 5? Okay, so let's think about our fraction. We have the number of times the desired outcome occurs. What is the desired outcome in this question? Well, rolling a 5. That's what they want to know. So how many times was a 5 rolled? We follow up the graph and we look to the left, and it occurred 8 times. Alrighty? So we would say 8 over how many total trials? Well, 50. We flipped that, we rolled that dice 50 times. Okay, 8 over 50. That can be reduced. 8 over 50 can be reduced to 4 over 25, which is 16%. Okay? So make sure you understand that one. If you need to listen to it again, you can. I'm going to erase it so there's enough room for the next problem. Okay, this time it says experimental probability of an odd number. Alright, so we know we have 1, 3, and 5 are our odd numbers on the dice. In 1 we got 10. 10. We rolled a 1 10 times. We rolled a 3 8 times. And we rolled a 5 8 times. So you're going to add up the 3. 10 plus 8 plus 8. And that would be 26. So the number of times the desired outcome, or what the question asks for, an odd number occurs is 26. And we still have 50 trials. That can be reduced. And you get 13 over 25. Go ahead and put that in your calculator. Divide 13 divided by 25. You should get 52%. Okay, so that is experimental probability. We use the data or some type of results in order to get our probability. Note that on 14 and 15, we're not looking for experimental probability, so do not use the data anymore. Because it says theoretical probability. So what is the theoretical probability if you have a dice of rolling a 5? A dice has how many 5s? How many favorable events or outcomes? How many 5s? It has 1 5. And how many total outcomes are there? Well, there's 6 because the dice has 6 numbers on it. Okay, so 1 6 is 16.6 repeating percent. How about the theoretical probability of landing an odd number? Well, on this dice, we have 1, 3, and 5. Those are our odd numbers. 2, 4, and 6 are our even. So we have 3 odd numbers out of 6, 1, 2, 3, 4, 5, 6, 6 options, which is half, and half is 50%. So theoretical probability, in theory, what's expected. Experimental probability, what actually happened. You're using results from a graph or from a chart or some type of results that they give you. Okay, the next part is for you to try. So I want you to answer these 3 questions before conducting the experiment at your table. I want you to answer number 1, it's theoretical probability. Number 2, theoretical probability. And then 3, I'll really quick go over. This is what must we do in order to find the experimental probability. All I want you to think about is if you don't get any data, there wasn't an experiment conducted. So in order to find the experimental probability, you actually have to conduct some type of experiment. Okay. All right, make sure you listen carefully for your next instructions. So once you've done 1 and 2, Mr. Mossberg will be checking those, but he's going to check those once you've done 1, 2, 3, the table, and number 4. Okay, so what I want you to do is raise your hand right now. Mr. Mossberg will hopefully come over and give you a dice. Okay, raise your hand and he's going to give you a dice. And you might want to pause the video. Once you have your dice, you're going to end up rolling that dice 20 times, okay? So, say on my first roll, I get a 4. I'm going to put a tally mark in next to the 4. Then, pretend I get a 3. I'm going to put a tally mark in the 3. Then say I get a 1. I'm going to put a tally mark in the 1. You should not be putting tally marks because you have not actually rolled your dice. I want you to do this on your own, okay? So once I have rolled 20 different times, so let's say I got 3 there, 5, 8, okay, so say I have all 20 of my tallies. What I'm going to do is I'm going to total them out. So this one has 3, this one has 3, this one has 5, and so forth. Okay, I'm going to total them out, and then I'm going to answer number 4. Number 4 says, what is the experimental probability of landing on a 6? So that comes straight from your data. Okay. Think about how you write experimental probability. So the number of desired outcomes, how many times that happened, over the total number of trials. You do not need to worry about number 5 and this little graph. That was going to be if I was at school today. So just through number 4. Once you've answered number 1, 2, 3, you have your little graph done, your chart, and then number 4, you can either go up to Mr. Mossberg and ask him to check it, or you can raise your hand and ask him to check it, okay? If there's any part of the video you need to see again, please rewind there, but I hope this was easy enough for you to walk through with me, and good luck on your reflection. I look forward to seeing you guys on Friday. All right, have a great day. Please be good. Bye.